So your table probably looks a lot like this. This one's a little bit differently though, because we can see already that we have different substances that we're dealing with. This table actually has to relate with the density of different substances. So density is something we haven't really talked about in class very much, but it's the amount of things or the amount of atoms or the amount of matter packed into a given space. Below you'll see that I have a bunch of Y's and a bunch of N's. The test that was run was essentially seeing whether something sits on top of something else. So all of these are in liquid state for the most part, with the exception of rubber. But it's all dealing with if things float on top of each other, if things sit on top of each other. We know that less dense things tend to sit above other types of objects and things like that. But if we're looking at just experimental data, the same thing can be said here. By looking for distinct patterns, we can see exactly what's going on, and seeing what's being tested, we can make some inferences about what's going on. So you notice that we have these black dot boxes here. Realistically, that just says that, like, well, we can't test vegetable oil being crossed with vegetable oil. That doesn't make a lot of sense. Those things are going to mix together because they're the same substance. So the same substances don't necessarily do anything with each other. The same thing is true of your table. The same substances probably aren't going to react. Like if we have a reaction between, say, lithium and lithium chloride, a single replacement reaction wouldn't allow anything to take place there. Lithium is going to replace lithium and nothing changes, nothing happens. The same is true for our density table here. Testing the same things doesn't necessarily make sense because, well, they're the same substance. They should have the same density because they're the same ideal quantity of stuff packed into that given space. But looking a little bit more at our data here, we can see things like, oh, isopropyl alcohol sits on top or floats on top of every single substance with the exception of itself. So we can say, oh, isopropyl alcohol must be our least dense substance. Kind of taking that leap a little bit further, we're looking for other things that are sitting on top of different substances. We can see that aluminum doesn't float on top of anything. It's always kind of at the bottom. It always has all of these no's. It's always sinking towards the bottom. There are no yeses for this one. And if even looking across this one, it says, realistically, all of these things float on top of everything. Everybody is yes here. That means, oh, aluminum must be on the bottom, so aluminum must be the heaviest thing. So realistically, my pattern here is that I have my least dense substance over here and my most dense substance here. So density in our table here increases as we go that way. So realistically, that's the same on both quantities, where I have my least dense substance up here, and it's going to our most dense substance here. But it allows us to build a pattern off of what's going on in our table here, just by looking at generalities, looking at things all the way to the left, looking at all the things to the right, making sure that everything falls within the same confines or the same pattern.